5G architecture based on NGMN envision. Based on the envisions of NGMN architecture of 5G is presented in figure 8, which leverages constructional separation between software and hardware. API are given to support multi-use scenario and the business model. The architecture is demonstrated in figure below. Architecture of 5G. Business application layer. 5G system. Business application layer. Use cases, business models, value proposition, operator services, enterprise, vertical, OTT, and the third party. The connected from E to E, management and the orchestra. And then these are not included in 5G. And then business enablement layer in 5G. Business enable APIs, library of modular network functions and value enabling capabilities, CP functions, up functions, thread configure, state information, info, command, common information repository. It is connected from E to E, management and orchestra. So then visualization. In this visualization, for example, this circle, external public private IP networks, infrastructure resource layer. These all are infrastructure resource layer. Here 5G devices. Here 5G rate family, rate 1, rate 2, rate 3. Here external public private IP networks. This is called access node. This is called cloud node, edge and central networking node. Recommendations. In this section we recommend the following areas to be work on for the architecture development of 5G. Data forwarding efficiency. This is business enablement layer, infrastructure resource layer, library and modules, network functions, values enabling capabilities. So common information respiratory these all are. So data forwarding efficiency, the benefit of virtualized network focused on NFV technologies and common equipment is the simplicity needed by the service scenarios. For single machine, the price of basic hardware is smaller than the price of specialized hardware dedicated technology through typically utilizes technology acceleration techniques that can increase forwarding efficiency. The benefit of recommendations in this section, we recommend the following areas to be worked on for the architecture development for 5G. Data flow forwarding efficiency, the benefit of a virtualized network focused on NFV technologies and the common equipment is the simplicity needed by the service scenarios. For single machine, the price of basic hardware is smaller than the price of specialized hardware dedicated technologies through typically utilizes technology acceleration techniques that can increase forwarding performance in order to achieve the same data forwarding efficiency, more standard hardware than specialized hardware is required at the current technology stage. That often implies more space and more energy use as the sequence visualization systems may be used first in the control plane. Fixed and mobile convergence software SDN. Fixed and mobile convergence software SDN. Since all fixed mobile networks have implemented SDN technologies to know if the communication systems of the two networks are incompatible and what are the differences, how to obtain efficient control and optimal routing is to be discussed in increasing potential user plane forwarding process and delivery scenario. How to obtain efficient control and optimal routing is to be discussed in the increasing potential user plane forwarding process and delivery. How to obtain efficient control and optimal routing is to be discussed in increasing potential user plane forwarding process and delivery scenario. How to obtain efficient control and optimal routing is to be discussed in increasing potential user plane forwarding process and delivery scenario. Network availability exposure. This is not originally intended for 5G. However, in the 5G period, the exposure of the network capacity would be broader and greater, coupled with the centralization of the network control functions. For simple network connectivity, usable APIs and interfaces between the network visibility module and the required network layer features needed to be further specified. Network capability exposure. This is not originally intended for 5G. However, in the 5G period, the exposure of the network capacity would be broader and greater coupled with the centralization of the network control functions. For simple network connectivity, usable APIs and interfaces between the network visibility module and the required network features need to be further specified. 5G 5G energy efficiency 5G energy efficiency. The current 5G structure indicates that energy utilization can be decreased to 10% contrasted with the present 4G systems. It includes the reduction in the power requirements of wireless base station antenna and client devices such as smartphones, tablets, and Internet of Things IoT devices to broaden battery life. Nowadays, the key component of designing communication network is energy consumption. Based on this factor of the networks are being developed. On account of the transformation of technology, the data transfer traffic in today's era is increasing every day. Due to this, the round trip time delay of the data packets rises higher in the network, which is turning into a more noteworthy issue for the energy cost on 5G systems. The cell system are uh, a fundamental source of increment in energy utilization in the telecommunication sector. The revenue energy consumption is the major challenge in meeting the green environment targets and the reduction in cost of system. Heterogeneous network is new trend which is increasingly day by day in order to enhance convergence capacity and power savings in the upcoming 5G network. The necessity for the energy consumption goal and operation will be significantly much more urgent with the advent of the 15th fifth sorry uh, fifth age of wireless system with hundreds of thousands progressively base stations and multi-millions of linked gadgets. It is expected that before the end of 2020, mobile access system will encounter critical difficulties when compared with the today's circumstances. Traffic volumes are expected to be much higher than the current rate, and the number of associated gadgets will be 10 to 100 times higher than today in the network. One of the enormous difficulties is to give thousand-fold increase in capacity for millions of gadgets in a moderate and economical manner. Energy use of the network is a crucial consideration to reduce the total cost of ownership. T, TCO, T for total, C for cost, O for ownership, including the environmental impact networks. This capability is the core design concept of 5G. 5G energy efficient green 5G, energy harvesting transfer, resource allocation, deployment planning, hardware solutions. Energy efficiency is defined as the number of bits that can be transmitted per joule of energy. Where energy is measured across the whole network, the 5G network will accommodate a thousand-fold rise in traffic in the next 10 years. Although the energy usage of the whole infrastructure is just half of the existing system consumptions. This drives the need for an improvement of energy efficiency of multiplied with x 2000 in the next 10 years. Every practicable effort must be made to gain energy without decreasing efficiency, but the technology should allow native flexibility for the operator to configure trade-off between performance and versus energy. There are different facts which make a 5G network as an energy efficient network. For the future, we have illustrated some of the parameters below. Sleep mode, high network data rate, dense small cell deployment, full duplex, massive MIMO, multiple input, multiple output antennas, multimeter wave frequency band. Sleep modes. The base station suggests itself into sleep mode during the cap activities on the network, thus reduces power consumption as the base station uses power even in high mobile networks doesn't surpass 20% of the gadgets in the new base. Okay. Base station enter into the sleep mode. Most of the base sessions remain ideal for throughout the period of 24 hours, and almost 80% of the power in any versatile mobile system is replaced by the base station in 24 hours. They can go into sleep mode repeatedly and remain for as long as possible. A technique to execute an advantage in sleep mode is discussed in that is on the idea of advanced sleep modes compares to a continuous deactivation of the base sessions parts so as to diminish the utilization of energy. That the author proposed a methodology to execute the advanced sleep modes until to overseas clients whose administration demands happen while the base session is in drowsy mode, as the basic base session needs to wake up occasionally to send flagging flashes. The author introduced a procedure to build the periodicity first to argument of the energy gains. The paper demonstrates system level simulation findings for hypothetical base session energy saving using a time triggered sleep pattern. multimeter